Good day! Welcome sa next lesson natin sa sequences. This would be the geometric sequence. So as with our discussion sa arithmetic sequence, tignan muna natin tong mga admittedly geometric sequences na to para makita kung ano yung pattern at bakit sila nagiging geometric sequence. So for this sequence, I want you to pause and construct the recursive and explicit definitions. Actually, I'll give two infinite number sequences. So the first is 81, 27, 9, 3, 1, blank. So identify that and come up with the recursive and explicit definitions. Give you some time, pause this video, compute nyo sa notebooks nyo, then let's compare our answers. Okay, alam kong ginawa natin yon. So let's compare our answers. Ano nakikita nating pattern? 81 to 27, 27 to 9, 9 to 3. We are dividing by 3 or multiplying by 1/3 to get to the next term. So if we're multiplying by 1/3, ang ating next term sa 1 ay 1/3. Ang ating explicit definition ay we are multiplying 1/3 or dividing by 3, yung previous term natin. Tama ba yan? Nakalimutan natin yung first term. So kailangan nating isulat palagi kung saan tayo nagsa-start if we are constructing a definition using recursion, or we're using a recursive definition. Our explicit definition would be the nth term is equal to 81 times 1/3 raised to n minus 1. So let's check. First term, syempre, n is 1, so the exponent is 0. So this will be 81 times 1/3 raised to 0. That's 81. Second term will be 81 times 1/3 kasi this will be 2 minus 1. Third term will be 81 1 over 9 is 9, and so on. So tama naman yung ating explicit definition. For our second sequence, pause tayo ulit. Try nyo uling hanapin yung explicit and recursive definitions. So, let's compare our answers. Tignan natin kung ano ba yung nangyayari. 1, papuntang negative 2, magiging 4, magiging negative 8, magiging 16. So, nag-alternate positive, negative, pero lumalaki. At in fact, nag-multiply tayo ng negative 2. So, ang next term natin ay negative 32. Since we're multiplying negative 2 sa previous term, ang ating recursive definition would be, I'm using h this time, the next term will be negative 2 times the previous term. And the first term is given to be 1. So we're multiplying negative 2 to get to the next term. Ang ating explicit definition, which we could compare, is negative 2 raised to n minus 1. So the first term is when n is 1, so negative 2 raised to 0, 1. When n is 2, that will be negative 2 raised to the first power, negative 2. When n is 3, this would be negative 2 raised to the second power, or squared, which is positive 4. So tama yung ating explicit definition. And I hope na pareho tayo ng sagot. Now let's define. Ano ba ang geometric sequence formally? A geometric sequence is a number sequence in which each term after the first ay ma-obtain by multiplying the same fixed number. So ano yung difference niya sa arithmetic sequence? Instead of adding a fixed number, which we used to call the common difference, we're multiplying by a fixed number. And instead of calling it the common difference, we're calling it the common ratio. So this is our recursive definition. The nth term is equal to the previous term times r, which is what we call the common ratio. And we could also express this explicitly as the nth term is equal to the first term times r n minus 1 times. So to get to the nth term, we are multiplying the common ratio sa first term natin, n minus 1 times. We could expand this similar sa arithmetic sequence na kung alam natin yung mth term, to get to the nth term, we are multiplying by r, n minus m times. And it works also even if yung m ay mas malaki sa n. Kasi magiging n minus m negative, then we'll be dividing r by yung difference nila. Now, let's take a look at some examples ng geometric sequences na problems. So first, we have the 8th term of a geometric sequence is 243 and the 5th term is 9. And we want to find the first 3 terms. So let's define our expressions. Since we're looking for the 8th term, let's call it g sub 8, that is 243. The 5th term, g sub 5, is equal to 9. We'll use our formula. Now, to get to the 8th term, we will multiply the common ratio to the 5th term 3 times. So 5, papuntang 6, papuntang 7, papuntang 8. And that's actually 8 minus 5 times. So our first task is to find the common ratio. So this would be 243 is equal to 9 raised to the third power, or r cubed is equal to 243 over 9, and 243 over 9 is equal to 27. So r should be equal to the cube root of 27, or positive 3. And now that we've found r, let's look for the first term. And let's use this formula again. The fifth term is equal to the first term times the common ratio r, multiplied 5 minus 1 times dun sa first term, or raised to 5 minus 1. We'll have 9 is equal to the first term times r raised to 4, but r is already known to be equal to 3. So we have the first term is equal to 9 divided by 3 to the fourth is 81, or 1 over 9. See g sub 1. So our first term is 1 over 9. The next term is 1 over 9 times the common ratio 3, which is 1/3. And to get the next term, we multiply this by 3, which is equal to 1. For our second example, we want to find the first term of a geometric sequence na ang binigay sa atin ay yung fifth term, which is 162, and the common ratio, which is negative 3. Let's write down our givens. The fifth term is 162. The common ratio is negative 3. I think this is just a matter of using the formula that the fifth term is equal to the first term times r raised to 5 minus 1, or r multiplied to the first term 4 times. Substituting our values, we have 162 is equal to g sub 1 times negative 3 raised to 4. And just get g sub 1 is equal to 162 over positive 81, or 2. So the first term of this geometric sequence is positive 2. Our next example is a bit more involved. Find the value of k so that the three consecutive terms 2k plus 2, 5k minus 11, and 7k minus 13 will form a geometric sequence. So our first term is 2k plus 2, our second term is 5k minus 11, our third term is 7k minus 13. Now, what do we know about geometric sequences? Well, the common ratio is yung ratio ng two consecutive terms. So it's equal to g sub 2 over g sub 1. It's also equal to g sub 3 over g sub 2. Now, substituting the given expressions for g sub 1, 2, and 3, this will be g sub 2 over g sub 1 is 5k minus 11 over 2k plus 2, and g sub 3 over g sub 2 is 7k minus 13 over 5k minus 11. And what are we doing? We're looking for the value of k, so we cross multiply. This would be equivalent to the equation 5k minus 11 quantity squared is equal to 2k plus 2 times 7k minus 13. Expanding our expressions, we have 25k squared minus 110k plus 121. This would be equal to the right-hand side, which is 14k squared minus 12k minus 26. Let's transfer all the terms from the right-hand side into the left-hand side, and we'll get 11k squared minus 98k plus 147 equals 0. So, please check na tama yung pag-subtract at pag-add ko. This is factorable. So, this factors to 11k minus 21 times k minus 7. Siyempre, is equal to 0. And by factoring it, na-solve na natin si k. We get k is equal to 7 and k is equal to 21 over 11. And this would be our final answer. Pero, check na din natin yung sagot natin. If k is 7, then 2k plus 2 is 14 plus 2, or 16. Tapos, 5k minus 11 is 35 minus 11, or 24. Tapos, 7k minus 13 will be 49 minus 13, or 36. So, 16 to 24 to 36. What are we doing? We are multiplying by 3 halves to get to the next term. So, this is a geometric sequence. Let's try 21 over 11. So, 2 times 21 over 11, that's 64 over 11. Sorry, that's 2k plus 2. Then 5k, 5 times 21 over 11 minus 11, that will give us negative 16 over 11. And 7 times 21 over 11 minus 13 will give us 4 over 11. So, ano yung common ratio from one term to the next term? I think we are multiplying by negative 1 over 4. Yun yung common ratio natin para maging geometric sequence ito. Kung sa arithmetic sequences, meron tayong arithmetic means, then inserting a number of terms between two terms of a geometric sequence, that would be finding the geometric means between those two terms. So similar idea dun sa arithmetic means. In this problem, or in this example, we want to insert 4 geometric means between 25 over 4 and 8 over 125. Let's illustrate yung problem. So between 25 over 4 and 8 over 125, we want to insert 4 terms, such that this would be a geometric sequence. Let's define our variables. Our first term will be equal to 25 over 4, and our sixth term, oops, I wrote g sub 5. It should be g sub 6. If you count, yung 8 over 125 is actually the sixth term. So it's 8 over 125. It should be g sub 6. I'm very sorry. So the sixth term is equal to the first term times the common ratio multiplied 6 minus 1 times. At least natama ko yung exponent. So we'll multiply r 5 times sa 25 over 4 para makuha natin si 8 over 125. Substituting our variables, we have 8 over 125 and 25 over 4 times r, di natin alam kung ano yung r, raised to the 5th power. So r raised to 5 is equal to 32 over 3,125. So 4 times 8 is 32. 25 times 125 is 3125. We take the fifth root of both sides and we get that our common ratio is 2 over 5. So to find the next term, we'll just multiply 25 over 4 by our common ratio, 2 over 5. We'll get 5 over 2. To get the next term, we multiply 2 over 5 sa 5 over 2, we get 1. To get the third missing term, we get 1 times 2 over 5 or 2 over 5. The fourth geometric mean is 2/5 times 2/5 or 4 over 25. Sulat natin yung sagot. Now let's check our answer. Isa lang man gagawin natin, we multiply 2 over 5 sa 4 over 25. And it's equal to 8 over 125. So tama naman yung solution natin dito. If we're only asking for one algebraic or geometric mean, then this would be equivalent to inserting a single term between two numbers, such that yung three numbers na yun, magko-form sila ng arithmetic sequence or geometric sequence, depending on what you are looking for. Now, let's figure out a formula to find the arithmetic mean or the geometric mean, kung isa lang yung hinahanap. So first, if we're only looking for one arithmetic mean, then we're just looking for one term between a sub 1 and a sub 3. The third term is equal to the first term, tas dalawang beses natin na-add yung common difference to get to the second and then to get to the third. And the second term is just the first term plus once ka mag-a-add nung common difference. Okay, let's use this equation para maka-solve na expression for d, then d is equal to a sub 2 minus a sub 1. Let's use these two equations para sa substitution, para makakuha ng expression. So, hindi natin kailangan yung d. So, we'll substitute 2 sa 1 in terms of d. So, a sub 3 is equal to a sub 1 plus 2 times d. But d is equal to a sub 2 minus a sub 1. Distributing yung 2, we have a sub 3 is equal to a sub 1 plus 2a2 minus 2a1. a1 minus 2a1, that's negative a1 plus 2a2. Yung negative a1, ilipat natin sa left side by adding a1 to both sides. And we'll have a2 is equal to a sub 3 plus a sub 1 divided by 2. So ano to? This is just the average, di ba, of a1 and a3. To find yung middle term ng isang arithmetic sequence na tatlong numbers lang, we just take the average of the first and the third term. So yung arithmetic mean, yung mean na ginagamit natin, average din siya, di ba? So the arithmetic mean of two numbers is just the average. Now on to the geometric mean. The idea here is that you have two terms, g sub 1 and g sub 3, tapos hinahanap natin yung middle term nila na magpo-form nitong sequence na to na isang geometric sequence. So g sub 3 is equal to g sub 1 na minultiply natin yung common ratio 2 times, but the second term is just multiplying r dun sa g sub 1. Once lang tayo mag-multiply ng common factor. Let's solve for r. Using the second equation, this would be r is equal to g sub 2 over g sub 1, second over first term. Tawagin nating equation 1 yung g sub 3 at equation 2 itong equation for r. And apply substitution, similar dun sa ginawa natin sa arithmetic means. Replacing r dun sa first equation, we'll have g sub 3 is equal to g sub 2 times g sub 2 over g sub 1 squared. Sorry, g sub 1 times g sub 2 over g sub 1 quantity squared. This would simplify to g sub 2 squared over g sub 1 kasi magka-cancel yung g sub 1 sa g sub 1 squared sa denominator. And if we multiply g sub 1 sa both sides, we'll have g sub 2 squared is equal to g sub 1 times g sub 3. Then we take the square root of both sides. And g sub 2 is equal to square root of g sub 1 times g sub 3. Now, technically, pwede siyang plus minus, no? So, we'll stick muna dun sa positive na g sub 2. So, the geometric mean is the square root of the product. So, similar siya sa arithmetic mean in the sense na mag-add tayo, then divide. Dito, magmumultiply tayo, then square root. So, that's how we find yung arithmetic and geometric means kung isa lang yung hinahanap. This is a very important concept in higher mathematics. And it's so simple na I think maintindihan nyo naman siya. Pero yung implications niya sa another set of, parang it gives us a tool for proving theorems. So the AMGM inequality, the arithmetic mean geometric mean inequality, states that for any two positive numbers, so sa positive numbers lang, hindi kasama yung negative, their arithmetic mean is greater than or equal to the geometric mean, always. Tapos nagiging equal lang ang arithmetic at geometric means kung yung dalawang positive numbers na yun ay equal. Siyempre, kasi yung average ng dalawang numbers, it's the same number. Kung i-multiply mo sila together, tapos square root mo, edi babalik ka lang din dun sa original value mo. Pero bakit siya palaging greater than kung hindi sila equal? So I'll just give two proofs na interesting. Here we'll use some algebra. So yung conditions natin, x is positive, y is positive, and they're all real numbers. Now by the fact no, na yung x minus y ay ni-square mo, this is already greater than or equal to 0. Kasi may squaring na nangyayari eh. Now let's note na magiging equal lang siya no, pag x is equal to y. Now let's expand our binomial. This will be x squared minus 2xy plus y squared is greater than 0. Then what I will do is I will add 4xy to the left hand side and the right hand side to maintain the inequality. So the left hand side becomes x squared plus 2xy plus y squared. Yung right-hand side, since nag-add lang naman tayo, greater than or equal pa rin siya, then it's 4xy. But notice that the left-hand side is a perfect square trinomial. I can factor it. Like so, x plus y quantity squared, it's still greater than or equal to 4xy. From here, we can take the square root of both sides. And since si x at si y, they're both positive, hindi na natin i-consider yung negative na condition. Kasi positive na sila to begin with eh. So notice, x plus y is greater than or equal to 2 times the square root of xy. Anong gagawin natin? And it will divide both sides by 2 to get x plus y over 2 is greater than or equal sa square root of xy. Or, the arithmetic mean is greater than or equal, where equality happens when x and y are both equal. There's another proof that I'd like to share, and it's pretty nice kasi medyo visual siya na proof. And we'll start with a semicircle. So let's locate yung center niya. So ito, kunyari. And then what I will do is I will drop a vertical line from anywhere in the semicircle, pero hindi natin kukunin yung gitna. Say dito. Such that it forms a 90-degree angle with the base of our semicircle. Let's label the bases. Let's call this x. Let's call this y. So notice yung x plus y na yan, that will be the diameter of the semicircle. If we draw this line segment, which is the radius of our semicircle, at ang diameter niya ay x plus y, then yung length nung radius natin would be kalahati nung x plus y, kalahati ng diameter, or x plus y over 2. This radius, this represents the arithmetic mean nung positive values natin na x and y. Now, onto the green line segment, we'll form a triangle by connecting the vertices of our semicircle dun sa endpoint nung green na line segment, like so, and like so. Now, I don't know kung naaalala nyo or naituro siya sa inyo, but any triangle na ang isang side ay yung diameter ng isang semicircle, tapos yung kabilang vertex ay nagtatouch dun sa semicircle, is always a right triangle. So let's mark this with a right angle. So kahit saan mo siya ilagay, right triangle yan. As hypotenuse yung diameter nung semicircle natin. Now since 90 degrees tong angle na to, at yung sum ng measurement ng angle na to at ng angle na to ay equal sa 90, kasi right triangle nga siya, at right triangle din to, then yung sum ng angle na to at angle na to, 90 din. Which implies that these two angles are congruent or equal yung measurement nila. So mark natin yun. And we've marked that those two angles are equal. And tawagin na rin nating L, itong line segment na to, para may notation tayo sa kanya. And if you're familiar with the concept of similar right triangles, then the ratio of the long side with the short side, hindi yung hypotenuse, so long yung short side, ng isang triangle ay equal sa ratio ng long to the short side ng another triangle na similar sa kanya. To use the idea of triangle similarity, yung ratio ng x over L sa ratio ng L over Y, they're equal. And if we cross multiply, we'll get the resulting equation that xy is equal to L squared, or taking the square root of both sides, you'll get L is equal to square root of xy, which is the geometric mean. Again, kukunin lang natin yung positive kasi yung L na yan, yung length na yan, it's always positive. So this length L, which is always shorter than the radius, is equal to the square root of xy, which is the geometric mean. At kailan niya mapapantayan yung arithmetic mean? Pag nasa gitna din siya, pag finorm natin yung right triangle natin na papaganito, in which case, x is equal to y. And that's it muna for our lessons on geometric sequences, and see you sa next lesson at sa next video natin.